So today I'm going to be giving a tutorial on creating a 3D segmentation geometry of the common carotid artery branching up into the external and internal carotid artery, and specifically with when it's filled with plaque, which is what our research is about. So it's more difficult than doing it with no plaque. So the software we're using is 3D Slicer version 4.11. There's a newer version 4.13, but that has some missing features. So once you've loaded up 3D Slicer, you're going to choose your images. You should load in all the images. So once the images load in, you should go to this drop-down menu and go to Data. And then this drop-down menu is how you're viewing the scans. You want to select red slice only, which is going to be looking at it from the top. That's going to be the view that we're going to be looking at using throughout. So again, we want to look for a high quality scan. This is, see the quality here is pretty low. That includes the neck region. Nope. And there's not a suitable scan here, actually. So I'm gonna load in another case. Carotid. Sure. Action. All right, let's try again with the set of scans and see, this is too low quality. This could be suitable. That's decent quality. It's not great, but that might be the best we have here. I hope. Oh, this is a lot better. Okay, so this is a suitable scan, and I'm going to check the laterality for this. I'm guessing it's right because on a CT scan, your left is right and your right is left. And you see this left side here seems significantly more blocked up. This is perichium. You can see right here, yes, it is the right side is blocked up. So the right side on the scan, the right side on the screen is going to be the left side. So next thing we're going to do is we're going to crop the volume. So we're only getting the part of the scan that we want, because that's going to make it a lot easier. It's going to help with the level threshold. So you see, we'd probably want to start about right here with a healthy artery. There's no plaque here. And we're going to make sure we're going to capture this entire branching region and then a few centimeters up from the branch. So up to about here. Yep, that's good. So now go to the drop-down menu, go to conventional, and edit the length of it, because again, you don't want to be segmenting more than you have to. And the key here is just make sure you get enough after the branch to be a little bit more here. That's good. Now coming down, you don't need to start up here. You can start above the lungs. So you see the lungs are right here on your scan. You can start above them. Would probably start a little bit higher. And that seems good. So now what I would suggest doing is naming your volume to the patient's last name and the side. So perichium R. How is that spelled? P-E-R. This is just so you know what you're working on. Now you're going to go to the segment editor right here. For master volume, you're going to select parachion R. That's the one you just edited. And you see it's much less restricted. And this is the region of interest. So if you're having trouble finding the region of interest, kind of look for this pattern. Look for the common carotid artery, and you're going to look for it when it's coming just up the lungs. So you can see starts right here. You can see it's on the left here, on the right here. And you can kind of just follow it up there. See, it's right here. So you really start from the top of the lungs, find the slightly lighter spot, and then you can follow it all the way up. That should be pretty easy. So now we start down here at the bottom, and now what I'm going to do is I'm going to apply a shift in basically the brightness and the contrast to make it easier to tell the flow lumen apart from the plaque and the surrounding tissue that isn't part of the artery at all. So first we need to define the volume. That is one nice thing about Slicer. It has this Python interactor. Now, once you define the volume, you can copy and paste the rest of this. And you see now here, the artery is much more self-evident. You can see right here, this is probably the narrowest spot right here. This area is the only flow lumen, probably in the entire artery. The artery should be about this size. So you see that's about 95% blocked up, if not more. So you can see it's very restricted. That's why they're doing surgery on these patients. So what I would suggest doing is moving, this is kind of your frame in the 3D model, but we don't need the 3D model. So we're going to go to red slice only. And then we don't need that. So now what you're going to do is add a segmentation, local threshold, and for your threshold range, I would suggest a minimum of 190 and a maximum of 500. And once you set that minimum and maximum, you should scroll through and make sure you're catching all the flow lumen. So for example, right here, for each patient, it's going to be different. So right here, you can see it's not catching all the lumen. You can see the artery more goes like this. So I'm actually going to lower it to about 180. And I think that should be slightly better. We'll go with 180. Again, if you go with 190 and 500, that's going to work pretty well, but it's better to customize it for each patient. And then for minimum diameter, keep segmentation algorithm on grow cut. For minimum diameter, you're going to start off at 0.5 millimeters. And then control click while you're over the artery, control click. So this is actually exactly what we wanted to happen right here. Well, down here, this exact one we happen. Up here, you can see this is segmented and is clearly not part of the artery. So there are two ways to get rid of this. The first is just to go into your 3D mode and erase it. The second is remove this segment, add a new segment. And we're going to turn this minimum diameter up to 1 millimeter and see if that fixes it. It's better to stay at 0.5, but it's not really going to hurt you. Nope. Let me try with 2. And here you're getting less of it at least. And here you can probably erase the rest in 3D view. So you can see right here, it's actually so tight around this area the algorithm doesn't even get through to this side. So what you're going to do then is go back to local threshold, keep the threshold the same, and add this branch of the artery to the segmentation. So essentially you're combining the two segmentations into one. And now if this extra stuff that isn't clearly part of the artery is not segmented, that's perfect. You move on to the next step, but in my case it is. So I need to go in here to 3D mode. I need to show 3D. I need to place the reference frame back on. And I'm going to quickly erase this in 3D. And you can pretty clearly see it, even if you're not familiar with the anatomy of this region. You can clearly see what's not part of the artery. So you're just going to click this box, edit in 3D view. And then you don't have to be super careful because you're still going to be editing the geometry a lot after you finish this. So if you make a mistake, you're going to be able to clean it up later. And now, the way you can tell this ICA and the ECA apart is, this is the ICA right here. And you can tell because the ECA branches. So this branch means that this part is the ECA. And you're going to want to remove these branches eventually. In your final geometry, you shouldn't have these branches. But I'm going to keep one just so I can know that this is the ECA. You can tell by looking 90% of the time, but this is a dead giveaway. So I'm just going to keep this there. And that's about all we can do in 3D mode. You see the geometry is still extremely poor around this bulbous region, this hole-like thing. This is pretty characteristic of Slicer's algorithm, but we're going to be removing all this and cleaning this up and connecting these manually. So I suggest removing that away. And we're going to start at the bottom. And you see, you're just going to scroll through this right next to the segment area. Click this button to toggle the segmentation on and off. So, for example, this part. This is all pretty clean. You don't really need to mess with Slicer's algorithm. This isn't the region of interest either. You could probably remove this part. It's pretty insignificant compared to the rest of the plaque, but I'm going to remove it for the sake of demonstration. That's probably not part of the flow lumen. You can see that's 276. That's pretty high for a corner. You see down on this corner, it's 180. So that's probably a little bit of plaque, but again, if you missed that, that's not a big deal. And you can clean up these parts. Again, you don't really have to worry. Slicer does a really good job on the part of the artery where there's no plaque. So you can pretty much scroll through this. And you see we still have no plaque, still no plaques. And this is the first slide where there's plaque. So you can see the plaque is right here. You can see these values are a little bit higher. So what I like to do is don't show that. You can see Slicer cut out a little bit of it itself. But again, you're going to get something like this. You do want to operate on the invisible segment, so hit no. And then you kind of just want to go in here and really, see, that actually looks pretty good. Really, I prefer not to look at the sites. You see, this right here is not flow lumen, neither is that. So again, you kind of want to go back. You can see there's kind of this region. There's lower values right here. There's lower values right here. And it's almost, there's plaque right here. So probably a line about right here. To the left of it is flow lumen, to the right, it's not flow lumen, you want to erase it. So that's fine. If I want to be really petty, probably goes up to there. You can see that. And right here, let's still erase this. Here looks good, looks good, looks good. And you see right here, this is not flow lumen. You're gonna want to erase all this. All this. That looks good. That looks better. And you can do this pretty quickly. I'm going a little bit slow for the sake of demonstration. But you just want to erase all this clotting. Clotting is lower values than it should be, and plaque is high values. So you see you've got clotting right here, you've got plaque right here. Actually got a little bit of clotting down here too. So for this, again, this is pretty easy so far. But I don't like these. That's pretty good. That's pretty accurate. And you don't have to be 100% accurate. You just need to get the correct flow areas of the artery. And you can see here, it's a little bit darker through here, but that's not enough to constitute erasing that. That looks pretty good. And again, you can go quicker than this. So right here, you have something interesting. So we've got plaque, and then this looks like it's flow lumen. This also does. So the artery might be branching here. You can see that's exactly what it does. So this is probably the last slide where before the branch. So this plaque right here, there's a line of plaque right here. This is the external carotid artery. This is the internal carotid artery. You can see it clearly here. This is the flow lumen for the internal, external, and they're clearly separated. So it's important to catch the branching where it actually happens, which is good. It's pretty self-evident here. And one reason for that is this is a asymptomatic patient. So asymptomatic patients are generally a little bit less fogged up than symptomatic patients, which is nice because this is an asymptomatic patient, so it should be a little bit quicker. That looks fine for the flow lumen for the internal. And again, a lot of this is just eyeballing it. Does that look right? Yeah, it looks right. So you can move on. The major point here would be catching the fact that they've actually separated. You see, Slicer is really bad at this. It can't see the separation. So this right here is completely wrong. And that's why you have to manually fix this. This is not flow lumen either. You can see there's just some beginning of plaque here. I would guess that plaque is, that's no plaque there. That's good. And again, this area right here, it looks almost like flow lumen, but it's not flow lumen because you get surrounded by plaque, the bottom right and to the top. That looks fine. And again, you can smooth this out in erasing in 3D. It's much quicker to smooth it using that than actually going through and smoothing all these originals, these actual red slices. You can see right here, there's a little bit, you can almost see a little bit of lumen right here. That actually might be a branch of the, no, that's just receiving plaque. Okay. So you would not want to include that. Just because you see it's here here, and then immediately disappears. So it's a tiny pocket of lumen directly above the plaque, and we don't need to include that because it's probably not part of the flow channel. So again, this geometry is pretty simple. The ICA is still almost completely cleared of plaque. The ECA is not bad. You've still got passable channel here. You can see, again, there's clotting on the top here, and then there's plaque on the bottom. There's slicer might be a little too generous with this top edge of that artery. That looks fine. And again, you're going to be going slice by slice. Usually there's not too many slices, so going slice by slice won't take you that long of a time. You can see right here, there's actually something very interesting. So the way we want to create these geometries, we want to just leave one flow channel at a time in any of the arteries, because if you have two flow channels, they separate and then they come back together to form one flow channel. That's going to create a hole, and we can't have a hole. So if there are two flow channels, really what you should do is you should choose the largest and go with it. So right here, these are still connected, but you can see here, this is almost two different flow channels right here and here. And you see this flow channel disappears. This is a really small flow channel, and it might make it through here, might come down the bottom here, but either way, we're not going to include it because we mainly want this flow channel right here. That's fine. That's fine. That's fine. You see slicers overestimating the flow lumen again. Probably does it here a little bit too. That's fine. That's fine. That's fine. And you can see right here, this part pretty much disappears, and that's fine. We're not going to segment this because that's going to create a hole, and that's a small flow channel compared to this one. This one is significantly larger. You can see here, this segment of the internal is why they did the operation, probably why they did the operation. And again, the plaque is kind of dying down, but you can see some clotting right here too. You still don't want to include that. And even right here, this is almost a little bit too light to be flow limit. So I'm not going to include that either. That's pretty consistent with the rest. All right, you can see you can see the multiple flow channels again. And just scrolling through sometimes it's helpful just to scroll through it without looking at your segmentation. There's some plaque in this flow channel. So again, the major flow channel is going to be this one right here. You can kind of follow it through there. So that's the one we're going to include. Again, if you segment two of the flow channels, it's going to create a hole, and that is pretty unworkable in the the CFD part of what we do after we generate these geometries. So you can see here Slicer probably underestimates the flow lumen. I'm gonna remove this here. And you can see this flow lumen disappears pretty abruptly. It goes over here, stays over here, moves over here. I'm going to give this one the benefit of the doubt, almost as if to compensate for the other flow channel that we can't include. Same in this slide. So you're getting kind of the right total surface area when you add them together. You can see there's ICA is branching, ECA is branching here. Actually, it doesn't catch the branch, so that's going to look really weird. Yeah, that's better. So this actually does a pretty good job of catching the expanding here. This is plaque, it shouldn't be included. This is obviously plaque. A lot of this is kind of just repetition. Once you do a lot of these geometries, you'll get the general picture. Follow through, and there we're good. So let's look through one time and make sure everything we've segmented is logical. So branching just about right here, a little bit of plaque, branching, branching, branching. Heavy plaque in the ECA. This disappears pretty abruptly. Very small flow channel. And then it comes back in. There's a lot of clotting here, a lot. So let's look at this in 3D. And that actually looks pretty good. You can see here, okay, this does not look pretty good. You can see here, and this doesn't look very good either, this bulbous region, but this is the narrowest part. There's not much plaque in the CCA. This looks to be a pretty accurate geometry. There's a few parts of this that we're going to need to address, though. The first is this little enclave in the CCA. You can see that's in this slide right here. Just going to leave that. And that's better. Now, this geometry looks pretty good. Well, I'm going to take one last look at this section, and I'm going to erase the branching now. And again, you can see the branching in the scan as well, but it's just easier to let Slicer find it for you. So I'm going to take a screenshot of this. And then I'm going to label it ECA and CCA, ECA and ICA. Later. And I do want to look at this bulbous region. There might be something we can do to mitigate this. I could just cut off this side. That's pretty clearly flow lumen, so I don't really want to mess with it. Which means that bulbous region, we might just have to keep that, even though it doesn't look pretty. Here we might be able to remove some of that. Here we might be, actually I don't like that. Yeah, I think that bulbous region is part of the artery. So it doesn't look great in 3D, but it probably needs to be kept. You can see that's a very complete geometry. So once you finish with your geometry, you're going to go up here next to segmentations, export to files. First, I need to create a folder for this patient. This is Parakion R. So save as, and then you're going to save it as an STL. It's the best file. Keep the size scale of 1, coordinate system LPS, that's good. Don't use compression, and you're going to export it. And now you've got your geometry. And now this is very important. Once you've exported everything, you're going to want to save. You're going to want to save this all. So save everything in this, and then you can reload it at this exact point, this current scene and slicer, which is what you're going to want to do. So now, if anything needs changing, it's really easy to change it. So you're going to want to save all of it. And there we go. That's our geometry. And you can see this is a pretty simple geometry, to be honest. There's no a more difficult geometry would have a lot of plaque in the branching area. But this one is pretty straightforward. You've got significant narrowing here, a lot of clotting, and really there's not much manual work you've got to do here. Slicer can do probably about half of it. So that's nice. Again, everything looks good. And there we have our segmentation. We have our 3D segmentation of the common internal and external carotid artery.